Hello everyone, welcome to this video on load flow analysis. In this video, we shall learn the comparison of load flow methods. There is Gauss-Seidel method, Newton-Raphson method, and fast decoupled method. So here are the various parameters we have used for the comparison. The first one is coordinates. So Gauss-Seidel method, it is normally done in rectangular coordinates. As we know that complex numbers, they are in rectangular or polar coordinates, and Newton-Raphson method, it is done in polar coordinates, so it facilitates easiness in the computation. Then decoupled method, it is preferred to perform in polar coordinates. Okay. Then the second one is arithmetical operations. So number of arithmetical operations. So in Gauss-Seidel, it is there are less number of arithmetical operations, whether it is addition, multiplications, in each iteration. Whereas in Newton-Raphson, the most critical part is Jacobian. So the computation of Jacobian matrix will take more more number of calculations, and here in fast decoupled it is lesser than Newton-Raphson method, as we have seen because of some assumptions and because of decoupling and assumptions. So the fast decoupled method, there are less number of operations. In respect of time, Gauss-Seidel method, it takes less time per iteration because of lesser number of mathematical operations, but increases with the number of buses. If the number of buses increase, then the time required for each iteration, that is, increases. Then the time in Newton-Raphson method, the time per iteration is 7 times of GS method and increases with the number of buses. Whereas in respect of fast decoupled method, it is lesser as compared to NR and GS method. Then in terms of convergence, so in terms of convergence, Gauss-Seidel method, here linear convergence is it is adopted in a GS method, and because of its the algorithm. And Newton-Raphson, there is a quadratic convergence in the mathematical calculations, and whereas decoupled method, it uses geometric convergence. Number of iterations, if you look at the GS method, will take large number of iterations, whereas Newton-Raphson, even though the time required per iteration is less, but the number of iterations are more. So overall, the total time required, it will be less than the GS method. So here only 2 or 5 iterations for practical accuracy. So it is more faster. A number of iterations, they are less, and so it is more faster than Newton-Raphson method. Then the slack bus selection, choice of, in the GS method, the choice of slack bus affect convergence adversely. Normally in the calculation, the first bus is taken as slack bus, and in Newton-Raphson method, sensitivity to this is minimum. So whether we have selected slack bus number 1, 2, or 3, it is immaterial. So it will not affect the computation, whereas fast decoupled method, it is moderately affected. The accuracy of GS method is less, and the NR method is more, and it is moderate for fast decoupled method. In terms of memory, because of less arithmetical operations, the memory requirement is less in GS method, whereas memory is more in Newton-Raphson method, whereas fast decoupled, because of simplification, only 60% of memory is required as compared to NR method. Usage, now in terms of power system, the GS method is applicable for small size system, whereas Newton-Raphson method, it is adopted for large system. And normally when you have to do multiple load flow studies, as in case of optimization or in contingency analysis or security analysis, fast decoupled method is used, or sometimes DC load flow is used. In terms of programming logic, GS method is easy, you can easily program, whereas Newton-Raphson is very difficult to program, whereas fast decoupled is moderate. In terms of reliability, GS method is reliable for small system. It is good for UNR method is good for large system and more reliable than NR method. So this is the comparison of load flow methods, um, Gauss-Seidel, Newton-Raphson, and fast decoupled method. So in this video up to this only. Thank you very much.